Hi students, so we are now in the second topic in statistics and probability. So in this lecture video, I'm going to talk about random variables and probability distribution. So for this lesson, we have the following objectives. Number 1, illustrate random variable. Number 2, distinguish between a discrete and a continuous random variable. Number 3, find possible values of a random variable. Number 4, illustrate probability distribution for a discrete random variable and its properties. Number 5, compute probabilities corresponding to a given random variable. And number 6, solve problems involving mean and variance of a probability distributions. So for our first lesson in statistics and probability, we talk about Sir Dom's discuss about random experiment. And when we say random experiment, it is any well-defined processes or procedures that produces an observable outcome that could not be predicted in advance. So in many random experiments, the sample points are not necessarily numbers, right? Say for example, if we toss a coin, the result or the sample space for that can be or are head and tail. So we need to quantify those sample points in our random experiment. So this quantification is achieved through the notion of random variable. So part 1 of this video is about random variable. And let's define random variable. So it is a function or rule that assigns a number to each outcome of an experiment, and it is also called a chance variable. Another definition, it is a numerical description of the outcome of a statistical experiment. So if you have, again, a random experiment or statistical experiment, let's say tossing a coin twice, we are going to associate numerical description to each outcome. Let's say, for example, the number of heads or the number of tails. Third, a random variable can be discrete or continuous. So later we are going to talk about discrete random variable and continuous random variable. And take note that when you're dealing with random variable, we are going to use capital letters to represent such thing. Let's go to the two types of random variables. Okay, so again, we have two types of random variables as presented a while ago. We have discrete and continuous random variables. So let's define each. So when we say discrete, from that discrete random variables, from the term itself, discrete, it assumes countable number of distinct values such as 0, 1, 2, and 3. So these are countable measures. Okay, so in this case, we can count the outcomes. Particularly, the outcomes can be represented as an integers. So we can associate an integers for such distinct values or for such values. And then for continuous random variables, it takes an infinite number of possible values. So it only assumes values on an interval or continuous scale. So what are those continuous scale? We have a weight of a student, height of a student, say for example a distance, or the time it takes for you to finish answering your assignment. So these are examples of continuous scale. Whereas discrete random variables, we have the number of enrolled students in senior high school. Let's say the number of pages in a book. So we can count the number of pages in a book. So these are examples of discrete random variables. Well, let's identify if the following random variables are discrete or continuous. So number 1, the amount of time to complete a task. Number 2, number of family members. Number 3, weight of employees in a BPO company. Number 4, student enrollment in Adno Senior High School. Number 5, lifetime in hours of 20 LED projection screens. So for this part of our video, you can pause for a moment and then try to identify Okay, the type of variables is presented. Let's answer these 5 items. So, amount of time to complete a task, we can associate this as continuous random variable. Because for the amount of time to complete a task, it can be, say for example, 1.053 hours, or we have 2.35 hours. Okay? O kaya naman, 2 hours, 35 minutes, 10 seconds, and we also have milliseconds. So, in this case, the result is not only an integer. Okay? Number 2, number of family members. Okay? We have discrete. Okay, we can count the number of family members. Number 3, weight of employees in a BPO company. This is continuous. Number 4, student enrollment in ADNO SHS. Okay, that's correct. We have discrete. Okay, we have discrete random variable. And then number 5, lifetime in hours of 20 LED projection screens. So some of you might be confused with this one. Okay, some might answer continuous, some of you will answer discrete. But the correct answer for number 5 is it is discrete. So why is that we have discrete? Since for number 1, the answer is continuous. But for number 5, we are also talking about lifetime. So we have time of 20 LED projection screens. So since we are concerned is the number of hours of an LED projection screens, so we are counting, okay, we are counting the lifetime of these projection screens in hours. It can be 2 hours, 3 hours, 5 hours, okay, 20 hours, 30 hours, and so on. So we are not concerned with the minutes, the seconds, the milliseconds, and all. So we're only concerned with the rounded value of, or the rounded time, say for example, of this projection screens, which is in hours. So we have discrete random variable for this. Okay, so let's say for example, weight of employees in kilograms in a BPO company. If we are asked to round off, okay, the data are rounded off to, let's say, the nearest kilograms, thus this measure is now discrete. Let's now proceed with the steps or assigning numerical values for our random variables. We have 3 simple steps. For number 1, we need to list all the possible outcomes of a random experiment. Number 2, count the sample points or the outcome of the assigned number and assign this number to the outcome. Number 3, make a conclusion for the random variable. For our example number 1, suppose 3 coins are tossed. We want to determine the number of heads that will come out. So let us use H to represent the number of heads and determine the values of a random variable H will take. Okay, so for our solution and steps, following the steps presented a while ago, we need to list all the possible outcomes of the random variable. So the sample space for such will be S is equal to this sample points given here. We have tail, 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 so meaning all 3 tails, tail, tail, head, and all heads. Okay, so after listing all the possible outcomes for this random experiment, number 2, count the sample points or outcome of the assigned number and assign this number to the outcome. So given this presented sample points in number 1, we need to count the number of heads. So for this, we are going to segregate the sample points. So we need to identify which of these sample points has no heads. In this case, we have tail, 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 and then among these sample points, alin dyan yung isa lang daw yung heads. So we have TTH, THT, and then HTT. For the 2 heads, that's THH, HTT, HHT, and then for 3 heads, that's HH, h. If we assign number, okay, for assign number for these outcomes, considering the number of heads for each sample points or elements, we can say that the values for the random variable h, which is the number of heads, are 0, 1, 2, and 3. So if we count the number of heads for this, we have 0, 1, 2, and 3. Thus, this random variable h will take numbers 0, 1, 2, and 3. Okay. Example number 2, we have let y be the random variable for the average height of a random group of 25 people. Okay, so for this example number 2, we cannot apply yet the steps presented a while ago, because in terms of the height of, let's say, these 25 people, we can have, say, 5 feet, 5.01 feet, and so on, because height refers to a continuous scale. So with that, if you know the resulting values for this situation, we can just say that the resulting outcome is a continuous figure, since height may be 5 feet, 5.01 feet, or again 5.205 feet. There are a lot of values that this certain situation may take. Same with the previous example. However, for such, we can count the outcomes. But in this case, for this continuous random variable, we can just identify maybe some of those outcomes. So let's say if you have random variable y, the possible numbers we can assign to this random variable y are 5, 5.01, 5.205, and so on. So depending on the height of these 25 people. Okay, so that's example number 2. Now example number 3, a car salesperson has arranged a visit on 3 prospective customers in a week. The salesperson wants to determine the number of sales, so let S be the random variable assigned to the number of sales. So let's create a tree diagram so that we can illustrate the given situation. We have 3 visits. So let's say, for example, we have S for the sale, successful sale, and then N for no sales. So for this one, we'll have sale, sale, and then sale, meaning 3 successful sales. SSN, SNS, SNN. What else? We have also here NSS, NSN, NNS, NNN. So if we associate numerical measure to this outcome for the, let's say, number of sales, we can have the sample space as 1. Okay, so with that, S will take the values 0, 1, 2, and 3. Okay, so this refers to the number of sales for these 3 visits. Okay, so we have 3 prospective customers in a week. So for this one, again, although we're not able to list the steps, but we follow the procedure given. We identify first the sample points, we assign numerical measure. So this numerical measure refers to the number of sales. We have 0, meaning no sale in a week. We also have 1, 2, and then 3. Okay, so that is for our example number 3. So for the second part of this lecture video, we are going to talk about probability distribution. Probability distribution is a tabular representation or mapping of all values of a random variable to their corresponding probabilities for a given sample space. So if you already assigned values or numerical values to the outcomes, we can find the probabilities now for such random variables. Okay, so how are we going to find probabilities for such? So basically, it is determined depending on the outcomes, the number of outcomes that we have. Another concept that you need to know that is related to probability distribution is the probability mass function. When we say probability mass function, it's a function similar to random variable, but random variable is more of assigning numbers. In this case, it is a function that assigns a probability to a discrete random variable exactly equal to some value. Also, please do take note that for the rest of the lesson, we are going to talk about discrete random variable. For the continuous random variable, it is concerned with normal distribution. So normal distribution will be discussed on the following lessons. Okay, so just to be clear with you that for the rest of the video, for the rest of the lesson, I'm going to talk about discrete probability distribution. So it can be an ordered pair because remember, a function can be represented as an ordered pair, a mapping, or in a tabular representation. You can also do that, and that tabular representation is about probability distribution. For mass function, it is a function or an ordered pair. Okay, we have the ordered pair x f of x. That is a probability mass function for the random variable x. Let's say if you have random variable, let's say x, assigned values are 0, 1, 2, and 3, we are going to associate probability for such 0, 1, 2, and 3. So let's say for 1, we have 0.5 or let's say 50%. So we have 1 and 50%. Halimbawa naman sa 2, let's say 2 and 18%. So it is an ordered pair. Okay, so we have to take note all of these properties, that the probability of simple events is greater than or equal to 0. Summation of the probability is always equal to 1. Okay, same with the probability of simple events, right? When we talk about that in lesson number 1. So the summation of the probability of simple events is equal to 1. So if we add all the probabilities of each random variables, that is equal to 1 or 100%. For number 3 or letter C rather, so we have the probability of x is equal to f of x. So this only means that the probability of this x, let's say value, is equal to f of x. Now let's go to example number 4. This is in reference with example 1. So let's have continuation of our example so that you know the relationship of the random variables and probability distribution. So construct a probability distribution for tossing 3 coins. Let h be the number of heads that will come out. So for our solution, take note that we had this table. What we're going to do now is to determine the probability of each outcomes. Okay, we have the probability of simple events. So we have the probability for the number of heads, that is 1 out of 8. 8 because there are a total of sample points. So we have 1 out of 8, 1 out of 8, and so on. So each sample points have 1 out of 8 as the probability. Now, in terms of the probability distribution, all we need to do is to identify or compute for the probability of each random variable. So we have for no heads, that will be 1/8, and then for the 1 heads only, so we just add these 3 probabilities. You have 1/8 plus 1/8, and then another 1/8. So the probability for 1 head, sorry, this is only head without s, we have 3/8. For 2 heads, that's 3/8 also, and then for 3 heads, we have 1/8 because there's only 1 outcomes with exactly 3 heads. As given this table presented here, we can now construct the probability distribution. So your tabular representation can be in horizontal or in vertical form. So in this case, we decided to use the horizontal form of the table. So we have the number of heads, so the assigned values to that are 0, 1, 2, and 3. And for the probability, we can have P of X or S of X, since S we use here to denote, rather, it should be H, sorry. So it should be probability of S of X or H of X. If we use H, that will be 1/8, 3/8, 3/8, and then 1/8 respectively. So we have here below the probability distribution for the number of heads when tossing 3 coins. Okay, so that's for example number 4. Okay, let's move to example number 5, which is in relation to example number 3 about the salesperson. So a car salesperson has arranged a visit on 3 prospective customers in a week. So based on the past experience, the salesperson knows that there is a 10% chance of closing a sale on each visit. To determine the probability distribution of the number of sales that the salesperson will take. Okay, so if we are to assign percentage for these successful and not successful sales, we'll have for sale, sale, and sale, that is the product of 10 and then another 10% and then 10%. So SSS will be 0.1 times 0.1 times 0.1, that is 0.001. For SSN, since the successful rate is 10%, meaning the unsuccessful rate will be 90%. So with that, we have 0.1 times 0.1 times 0.90, and that will be equal to 0.009. Okay, we also have SNS, so 0.1 times 0.9 times 0.1, that is also 0.009, up to this 3 no sales. So we have 0.9 times 0.9 times 0.9. So we have 0.729, which is in percentage around 72.9%. So the probability for no sale is quite high compared to the successful sales. So we have 0.729. We need to construct probability for such. Okay, so that this car salesperson know the probability that there will be sales or no sales in a certain let's say visit. Okay, so we have the following outcomes. So I listed here all the outcomes. You have sale, 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 and then no sale. So we count here the number of successful sales or the number of sales. So we have here 3S, so X will be 3. SSN, so we have 2 sales, that's 2. SNS also 2. SNN, we only have 1 S. NSS, we have 2. NSN, we have 1 S. NNS, also 1 S. And then NNN, meaning no sales. So for the probability, we also take note their corresponding probabilities. So this is still based on this illustration. Okay, considering that for the successful sale, you only have 10% and then 90% for no sale. Okay, so with that, the probability distribution will be given by this. We have X, B, 0, 1, 2, and 3. This refers to the number of sales. And then S of X, this refers to the probability for the number of sales. So 0, that's 0.729. So saan naman galing yung 0.243? Is we only add those probabilities for X equals 1. So we have here 0.081, another 0.081, and then 0.081. So if you add this 3 0.081, the result will be 0.243. Same with with 2, x equals 2. If we add the probabilities assigned to x equals 2, we have 3, by the way. We have 3. So, yung nasa second row, third row, and then the fifth row. So, we have 3, 0.09. And if we add this, we'll get 0.027 or 2.7%. And for the probability of 3 successful car sales, that is, let's check on this, only 1, okay, outcome with 3 successful sales. And the probability assigned to that is 0.001. So with that, in our probability distribution, we have here. And please do take note that if we add these probabilities, it should be equal to 1, okay, or 100%. So for the success rate of 3 sales, okay, we have only around 0.1%. For 2 successful sales, that's 2.7%. That is, again, take note, these successful sales in a week. Okay? For the no sales, we have 72.9%. Okay? So that is our example number 5 in reference to example number 3. Okay? So don't forget about this because later on, we're going to use them pa naman. Okay? So, let's go to histogram. So, since meron tayong tabular representation, meron din tayong mapping for the probability distribution, meron din tayong graphical representation. And that graphical representation is known as the histogram. So, it displays data by way of bars to show frequency of numerical data. What is the difference between histogram and bar graph? Bar graph is a pictorial representation of data that uses bars, diba, to compare different categories of data. But in histogram, it displays data by way of bars also to show the frequency of numerical data, okay, as presented in this definition. So, in histogram, it indicates distribution of non-discrete variables, while for bar graph, it is a comparison of discrete variables. Histogram is more of the quantitative data, while bar graph is more of categorical data only. Okay? In terms of spaces, so as you can see in this illustration, in histogram, bars touch each other. Except to this one here, wala sa 60 because it means that there is no assigned probability for x equals 60. Okay? So, there's no space between bars. But in bar graphs, okay, bars do not really touch each other. So there are spaces between bars. So in terms of the width, diba, in bar graph, the width should be the same. Okay? So you have to have the same width for each bars. But in histogram, it doesn't necessarily mean that we have same. In terms of the elements that we can find here, for the x-axis, we put here all the x values assigned to random variable. And then for the y-axis, we can include frequency o kaya naman yung probability mismo ng random variables. So let's say for example here, example number 6, this is in reference with example 5. We are asked to construct here histogram for the probability distribution. And we were able to construct already probability distribution in example 5 or task number 5. In this case, we have the x and y axis with labels 0, 1, 2, and 3 on the x-axis, and then y-axis we have the probabilities. Again, for the histogram, your y-axis refers to the frequency or if not the probability of the random variables. For this histogram, the first bar will be at 0, whose height is 0.729, because the probability for the number of sales, which is 0, is 0.729. The next value will be 1, and the probability for such is 0.243. Third number is number 2. We have the probability is 0.027, and then last but not the least, for the number of sales, which is 3, the probability for such is 0.001. So this will be the histogram for the probability distribution of the number of sales that the salesperson will make. For example number 7, this is the histogram for the probability distributions of tossing 3 coins. So we have the corresponding probabilities. We have 0 and 0.1 for the exactly 1 head, that's 1, and 0.3. So meaning we have the probability is 30%, if not really 3, because it is greater than 30% if I'm not mistaken. Same with 4, so it is around 33 or 36%. So for 3, we also have the same probability with 0. So the histogram for such random experiment and probability distribution at the same time is presented here in our screen. Okay, so the last part of this video is about the mean and variance of discrete random variable. Okay, in probability distribution, the expected value or the mean of a probability distribution is the weighted. This is the weighted average of possible values of a random variable. So with weights given by their respective theoretical probabilities. So it can be calculated by this presented formula. So we need to multiply each of the possible outcomes by the corresponding probability or the likelihood of each outcome will occur, then summing all those values. So we have, let's say, mu. This is the notation for the mean of a probability distribution, or also known as the expected value, is equal to x sub 1 times probability of x sub 1 plus x sub 2 times the probability of x sub 2 up until x sub n. Or after which we take the summation of all these values. So we have mean is equal to the summation of the product of x and p of x. Okay, so that is for the mean of probability distribution. So aside from the mean of the probability distribution, we also have about variance and standard deviation. So this is also in relation to the probability distribution that was presented a while ago. I think most of you have ideas about variance and standard deviation when summarizing data, right? So in this one, the difference here with the standard deviation and variance, or the measures of dispersion that you know, is that we are referring to the properties of the distribution of a random variable. So somehow, in terms of how we compute for the variance and standard deviation is different. Also, the property that is also concerned to this measures of dispersion is different from the measures of dispersion that we know when we summarize a data. But the idea is, if you have small standard deviation and or variance, it means that the distribution of a random variable is normally concentrated around the mean. And if you have large standard deviation or variance at the same time, it means that the distribution is spread out. So say with some chance of observing values at some distance from the mean. Okay, so at this point, we can use any of these two formula for the variance. So either the variance of that probability distribution is equal to the summation of the product of x squared and p minus the square of the population mean. Or it can be the summation of the quantity, the x minus the population mean squared times their corresponding probabilities. And for the standard deviation, we know that the standard deviation is the variance, the spirit of the variance. So once you have the variance, just get the square root of such and you'll arrive at the standard deviation. Okay, so this will tell you about the dispersion of the data from the mean. How dispersed the data is from the mean. So let's go to the next example. Let's try to find the expected value, variance, and standard deviation for this distribution. So suppose an individual is playing a gambling. So it is possible to lose 50 pesos. Can be break even, so meaning no loss, no gain, win 150 pesos or win 500 pesos each time he plays. So the probability for each outcome is provided here. We have this table. So find expected value, variance, and standard deviation for this distribution. So unahin natin yung expected value. So if we compute for the expected value, we have to use this formula as presented a while ago. So all we need to do is to multiply first the outcome and their corresponding probabilities and add all those values. We'll have negative 50 times 0.035 plus 0 times 0.45 plus 150 times 0.15 plus 500 times 0.05. So this will be equal to 30. Deviation mean or the expected value of the probability distribution is 30. So this is our expected value or 30 pesos. Okay. So in relation to the variance and standard deviation, first is we can construct table so that we can easily find the variance, because this computation is quite tedious if you're going to work it by hand. Okay, so for the variance, we have the outcome for the first column. Second column of that table is your probability. So if this table presented and the problem is rearranged in such a way na yung kanyang orientation is now vertical, we'll have the first two columns. Yung third column natin, that is the difference between the outcome and the population mean or the expected value. Fourth will be the square of the difference of the outcome and the population mean. And for the fifth, we just have to multiply the value from the fourth column to the second column. So for the third column, we have negative 80. That is because you have negative 50 minus 30. So that's negative 80. Ano pa? 0 minus 30, that's negative 30. 150 minus 30, that's 120. Again, yung 30, saan galing siya? Doon sa expected value. So, if x is 150, we have 150 minus 30, that is 120. We also have 500 minus 30, that's 470. Okay? So, after which, just square those values on the third column. So, square of negative 80, that's 6,400. Square of negative 30, we have 900. Square of 120, that's 14,400. And then square of 470, that's 220,900. After which, i-multiply mo lang yung nasa fourth column and nasa second column. So, 6,400 times 0.35, that's 2,140. 900 times 0.45, that's 405. 14,400 times 0.15, that's 2,160. And 0.05 times 220,900, we get 11,045. So if we add these values on the fifth column will arrive at 15,850 pesos in terms of the unit of measure. So this will also serve as the variance of the given probability distribution. Now, in terms of the, let's compute for the standard deviation. So for the standard deviation, since nahanap mo na ang value ng variance, just take the square root of the variance. So the square root of 15,850 will be 125.9. So this will tell you about the dispersion of the data. So the higher the standard deviation, the variance, the dispersed the value is from the distribution. So in this case, 125 and maybe 90 centavos for this problem. Okay, so that is example number 8. Example number 9. A financial consultant believes that each savings account customer has, on average, 2 credit cards. So the following distribution represents the number of credit cards people own. So find the mean, variance, and standard deviation. And then answer is the financial consultant correct that on the average there are 2 credit cards each customer has. Okay, so for our expected value or the mean of the distribution, we'll see we have this formula again. So next we substitute the values. So we have 0 times 0.08 plus 1 times 0.5 plus 2 times 0.05 plus 3 times 0.19 plus 4 times 0.18. So if we add the product of each of these, we'll have 1.89 or approximately 2. So at this point, you can already answer the question, is the financial consultant correct? We can say that yes, because 1.89 is approximately 2. So this refers to the average number of credit cards. So we have 1.89 or approximately 2 credit cards. So the financial consultant is indeed correct. Okay, so now with regards to the variance and standard deviation, let's move on to this one. So we create a table again. First and second table refers to x and p of x. Now your x minus mean, that is 0 minus 1.89. Next is 1 minus 1.89, so that's 0.89, 2 minus 1.89, 3 minus 1.89, and then 4 times 1.89. So we have these values in the middle column. On the fourth column, just square these values. As you can see, we use 4 decimal places for this one. So 3.5721, that is the square of negative 1.89, 0.89, that is the square of which is 0.7921, and so on up to the square of 2.11, that is 4.4521. Next, for the last column, just multiply the values on the fourth and then the second column. So we'll have 0.29, 0.40, 0.0006, 0.23, and 0.80. So adding these values in the last column, we'll have 1.72. So the variance of the probability distribution is 1.72. Okay, so that is for the variance. Now for the standard deviation, just take the square root of 1.72, and this is 1.31. So the standard deviation for the probability distribution is 1.31. You can actually construct histogram out of this problem. So just take note that for the x-axis, we have 0, 1, 2, 3, and 4. And then for the y-axis, we have these corresponding values. Okay? So you may construct histogram for us your practice exercise for this video and for this session. Okay? So now, let's see if we were able to discuss all of the things that are required for us to know in this lesson. First, we were able to illustrate random variable. Second, we were able to distinguish between discrete and continuous random variables. Number 3, we were able to find possible values of random variable. Fourth, illustrate probability distribution for a discrete random variables. Yes, we were able to talk about this one. Computing probabilities given a random variable. Also, yes, we were able to discuss this. And then solving problems involving mean and variance, and at the same time standard deviation of probability distributions. Okay, so that's all. Thank you so much for watching the video.